I'm going live, and I'm live. Yes. Did I tell you what I recently got for Christmas? I got an Elgato video card. It's something like the size of a deck of cards, but I could plug it into the computer, and I can plug it into my Switch, and I can play the Switch on the computer for live streams. Just saying. It's amazing. I love it so much. Anyway, I don't know. I was just... Oh, man. My brain is all over the place right now. Anyway, here we are on Friday. We have 1, 2, 3, 4, 5, counting today, 5 more class periods until final exams. A couple of those class periods, of course, I would like to be reviewing with you guys. So everything that we've done from the beginning of the year. And so that really leaves us like 3 class periods or so to get done exactly what I need to get done. And I have plans for today. But first, oh, hello, good morning. People are saying hi in the chat. It's just Sky. No, it's always Sky. But anyway, I lost my train of thought because I was saying hello to her now. Anyway, I had assigned for you some... Hello. I had assigned for something for you in Google Classroom. I'm just double checking. I believe I had it due today. Yes, at 2 o'clock, something on binomial and geometric. Now, with that, yesterday, hold on, there's a bell.
Mr. Smith, please call the main office.
No, it wasn't yesterday, it was Wednesday. On the Google stream on Wednesday, I posted a link to the video of me reviewing those quizzes questions. So we took the quizzes on Wednesday, and I wanted to review those questions. So I created a video to do that. So this is what I'm going to say in regards to it. I'm just double checking right now. Yep, it's like an 18-minute video. Obviously, that's up to you. It's not mandatory to watch, but it's up to you. If you want to review that information, that would be incredibly helpful. But that was posted on the Google stream on Wednesday. Like I said, there is an assignment, binomial geometric. The directions are all there. That's due today. What I'm going to say is this in regards to binomial geometric. That assignment I want done, and I am going to be assigning a minor assessment in regards to that information. So you do have the video, you do have that homework assignment that's up there right now, and there is going to be an additional minor in regards to binomial geometric. So we'll be able to get that thing done. Today, I am going to be going in a slightly different direction, simply binomial geometric. That's all that we honestly needed to cover from it. So I'll be able to you guys will be able to knock out this assignment due today and the minor assessment that I'm going to be posting later today. And that'd be great. But today, breathe this in for a moment, the next statement I'm going to make. Breathe this in. Ready? 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 I'm going to begin the last topic that I'm going to be covering with you in Prob and Stat. The last topic. Breathe that in for a second through your masks and whatever else is in there. I don't know. Can I tell you a silly story from wearing a mask? I'm going to tell you anyway. Doesn't matter. We were wearing masks for like however many months. And then it was like in November. I'm sitting at my desk and I couldn't stop like coughing, sneezing. And I didn't know what it was. And I was the only one in the room. And I swear to you, I was just like, what is, like, something's like really messed up. And I thought it was like my beard hair. That was like, you know, I don't know. You guys don't know. I thought it was beard hair up my nose. Pulled it out. It was like a string that long up my nose from a mask. Yeah. I just thought that was funny. I don't know. There you go. So, I don't know. But today is the last topic that I want to be covering. Now, in order to introduce that topic, I do have a couple of videos, short videos, that I want to show you in regards to the pole vault. You guys know pole vault? You know how dangerous the pole vault is? Pretty much. You have no control over it. I'm sorry, you do have control over it, but yeah, if it breaks, you're like, oh, this is how I die. Oh, gosh. Sorry, she's asking me, like, how did I even manage with the thing. Anyway, so I just wanted to kind of show you what the pole vault is all about. So I have a couple of videos here that I'm going to queue up. One is from 1924. And there's a reason why I'm comparing the two of them, because I want you to pay attention not only to the techniques and stuff like that, but also the height that they actually get on this on these things. Now, this is just a 1-minute video showing footage from the 1924 Olympics. Just watch this real quick. I got the volume turned up. Oh no, I muted it, so whatever. There we go. But like, what do you see about the heights right there? So it's just under 4 meters. But this is 1924, and these are the men. Slow motion. Woo! And the world record, you can see, 4.21. So that was 1924. This is from 2004. This is from 80 years later. I feel like the music in this is pretty good. Wait, what was that? Oh, the other video. There we go. So watch this real quick. My opinion. Let's watch the focus. Now, at this point, you don't know it, but she has pretty much secured herself. She's secured herself the gold medal, but she's still going to be jumping. Now, look at this. The men's record back 80 years ago, the men's record was 4.2 or whatever the heck that thing is. And now she's like 4.8 or something here. Hold on. I don't know what the men's record is, which we'll talk about. 80 years difference. Also, she has this chain stuck in her mouth. I don't know what the deal with that is. Now, it's for the women's world record, I should say. Well, she's going for right now, 4.91 meters. It's like 18 or 19 feet, you know? Hold on. What was that? What was the last part? I can never do that. Like, well, there was one. Hold on, that I saw that I skipped over.
Are we trying to send number 2? Yeah.
Yes, because I have you do different problems. Do you know what I'm talking about?
Yeah, B, C, D, and E.
Yes, I have you do problems that we did not do in class. Yes, that is due at 2:00 today.
Wait, so we're doing the ones for part 1 that we
Can
did.
someone from technology
Wait, 1 second.
please call the main office?
That's right.
Technology, call the main office.
Go ahead.
So the ones that we did do in class, we do those too?
Only the ones that I assign. So, for example, if I go to Google Classroom right now.
It's not like that.
Mhm.
I literally every single question.
Aren't we doing to see it.
Right there, the ones that I highlighted in the little in the directions. It's in the Google Classroom. Just you're not doing every letter. Trust me, you're not doing every letter. But yeah, you'll see. You'll be able to get that thing done. Here, I'll just show you. This is the last one I'll show you. I didn't intend on showing this, but apparently this one. Oh no, this wasn't it. Hold on. Where was it? Oh, I thought I picked the one where the guy broke his pole, or the girl broke her pole. There it is. I found it.
Of Sweden. Watch what's happening here on her third attempt.
Whoa! Now, don't feel bad for her because she actually breaks the world record in her neck.
Of Sweden. Watch what's happening here on her third attempt.
Choo-choo!
You never want to see anything like that. Obviously, guys, pole vault's the only sport and the only event in track and field. Your life is in your hands. You have to trust what's in your hands. It's so dangerous to do what these women are doing. See in slow motion how close she was to landing completely in the box.
Well, the good news was she was okay. The better news is she's afforded another try as a result of that.
So here's her next try.
Third attempt.
So don't feel bad for her.
Join them at the next height.
Woo!
And putting the trust in her new pole, she gets over the bar. That's a new outdoor lifetime best. The first time we've ever had 5 women over that height in any competition ever, reinforcing this idea that this is the deepest field ever in the sport.
So yeah, that was just, I just thought that was kind of cool. So here's what I would like to do. I'm going to post something into the Google Stream, a PDF for those of you that are watching on the computer. But for those of you that are here, I got this for you. Now, you will need your Chromebooks for the assignments that I got for you here. There you go. You will need your Chromebooks because we're going to have to enter in some data. Obviously, we'll need the graphing calculators as well. I mean, the graph calculators on your Chromebooks. So let me find the file that I'm looking for. If it'll actually load. Where are you? Let me check the drive then. I know exactly where the file is. Let's see here. There it is. Ba-boom. I'm going to post this PDF for today. So the people, there we go, in the live stream can see exactly what we're referring to. So I posted that so you guys can open that up and that'd be great. But what you have here are heights in the Olympics for the pole vault. The table gives the Olympic pole vault records in the 20th century. Now you can see there's little notes there in the table saying that instead of actually using the year 1900, they want you to use the year 0. I'm going to show you how you can use the graphing calculator to do an analysis on this information. So the first thing that I'm going to ask you to do, open up those graphing calculators. I'm going to open mine up on the... There we go. Excellent. I'm going to clear mine out. Second, plus sign, 712. Mine doesn't clear out, but yours does, right? Yours says RAM cleared right when you open it. Cool. Mine doesn't. I don't know why. Anyway, here's where you need to go. Okay, there's this button that says Stat. You're going to hit Stat, and you're going to hit the button for Edit. Now, we've probably done similar information to this before, but we've never run a linear regression, a linear analysis on our data, which we're going to do today. In the first column, I'm going to follow the directions on this particular paper where they say, okay, year 2000. By the way, what number are you going to use for the year 2000? Yeah, you're going to use 100 for the year 2000. Yes, because that would be the number of years after 1900. So you enter in your data into the graphing calculator. I'm going to enter in my data, and we'll reconvene in a few moments. Just make sure you're only typing in the numbers needed from the table. Here we go. 1, 2, 3, 4, 6, 7, 8, 9, 12, 15, 18, 21, 24. Good. And in the right column, I'm going to enter in my data as well. Up. Oh, she said the stream skipped and paused. I'm sorry about that. I hope it's working now. Now, while you guys are finishing that up, I'm going to tell you exactly what we're going to do. First, we're going to have the calculator show us a scatter plot of the data so that we can do just a brief analysis as to what it looks like. And then after that, in order to create a prediction equation. Now, we're going to write down some of this information into our notes in a little bit, but I wanted to do this particular thing first. It's been 84 years. In your calculator, once you have that data entered, first thing we're going to do is we're going to try and figure out how to create the scatter plot. First of all, is there any button that has anything to do with plots? Let me see. Trace, I don't see plot on trace. I see trace and calc and all that other stuff. Above the y equals. That's exactly where we need to go. If you hit the buttons for second, y equals. This screen with all of these plots. What do you notice about all of these plots? What do you notice? Something that we do need to know about all these plots. It's something that kind of just screams off of the screen. That's true. What else, though? The what? They're all off. They're all turned off. You need to turn one of them on. That's exactly what we're going to do. Now it's on. Now, notice everything else that's kind of up here. We've done similar in the past and things of that nature. Box and whisker plots. But this thing is automatically a scatter plot, and it's automatically set to L1, L2 for your X values and your Y values. Good, and good. Now, you could hit graph, but graph is not really going to give you all of your data. If you hit graph, it's just going to give you a few of your data points. That's not going to be incredibly helpful. Instead, we need to fix the for all of the statistics that we entered. And the way we do that, there is a button in the top middle called Zoom. There is a button in the top middle called Zoom, and there is an option once you click that, one that we need. If you hit Zoom Stat, it automatically resizes your window to fit statistics that you entered. Couple things about this scatter plot. What direction does it seem to go in? Kind of like the cow says moo. Direction is it going? Yeah, well, right and up. That's the key, though. It's right into the up. It's going in the positive direction, called linear regression. So we're trying to describe this thing in terms of a line. It has a positive x values on this graph. Your x values represent the year or the number of years since 1900. Numbers on the y-axis represent the height of the pole vault in meters. This should make sense. The closer you get to modern times, be. Why is that? Why do we assume that records will improve as time goes on? Or athletic records, I should say, at that time. Different ways of training, advanced ways of doing it. What else? They build upon the techniques of previous generations. Sure. So they train harder, or they train better. They have better techniques. There's one more thing that kind of comes into play. Do you know? Tell me, what did football players wear on their head in the 1920s? Nothing, or like leather straps. And now what do they wear today? The course of time. Equipment improves. Equipment. So for the pole vault, you got better shoes for speed. You got better poles that shouldn't break. You know? Some do, yes, I know. But over the course of time, it improves. That's just what happens. Sheet that I gave you, it says, find the regression line. Ugh. Back in middle school, I know you don't want to think about middle school, but let's talk about middle school. Check this out. Back in middle school, you would create a scatter plot, and then you would actually have to, something like that. And then you'd have to find the equation of that line. Meh. The calculator's going to do it for you. The calculator is going to, again, in the middle column, if you hit stat and tab to the right, to the word calc. Now, we've been here before, but where we're going now is the fourth option. The fourth option being lin for linear regression. And if you hit lin reg, you come to this screen. It's automatically set up for you for L1 and L2. Don't change anything. Calculate. And it will calculate your linear regression. Now, what you're going to write down on that piece of paper, I'll flip over my screen in a moment. There we go. And flip that over and zoom in. Zoom in. It'll focus in a moment at the top of the page. There it is. That information is what I would need to write. Y equals 0.028x plus 3.4. Because when you run the linear regression, there you go, regression, it will spit out the appropriate numbers for slope and y-intercept. Going back to the calculator real quick. There we go. You can see at the top, it gives you a y equals ax plus b, similar to mx plus b. Spits out those appropriate numbers for slope and y-intercept, which is really nice. That equation is what we refer to as a prediction equation, which is really nice. That equation is what we refer to as a prediction equation. It is not actually what happened, but using the data that they gave you, it is making a prediction. Now, let me actually take that information and let me put it into my y equals key. I'm going to ask you to do the same thing. I'm going to put this into my y equals key. There we go. Because I want to see that line, and the line of best fit is attempting to follow the trend of the data. It's attempting to follow the pattern that is. Sometimes it nails it right on the head, sometimes it misses the mark. But that's just the way that this thing is calculated. You can see somewhere in the middle right here, there was a bunch of data points that underperformed, formed where the prediction was. The prediction overshot what ended up happening. But that's an opinion question almost. What seems to be happening in more recent years? It seems to be slowing down. It seems to be reaching a plateau. That the pole vault record will keep just going up and up and up and up. I don't know. Maybe it will. This is the line of best fit. Yeah. And then you're absolutely right. In the beginning, and this is part visually, you can see, well, at first, up until maybe like the 1960s, it was plateauing. And then maybe there was a huge advancement in technology or equipment where it's plateauing again, and then maybe we'll hit another major leap in technology. I don't know. She was going to suggest plateau. So let's take a look at some of the questions on this worksheet. And then I'll hit some of the notes in a little bit. It says to make a scatter plot on your calculator, done. Regression line appear to be a suitable model for the data. Does it appear to be a suitable model for the data? Well, again, it doesn't have to be perfect, but this one is. This one is. The data seem to be quote unquote straight enough. It seems good. Follows the trend of that data. Let's go with yes. And I'm going to say this is a soft yes, because it does say, does it appear to be a suitable model? Not that it absolutely is, but yeah, it kind of looks like it. All right. Part C, to predict the 2004 Olympics. So we're going to do a prediction versus the actual. How do I make that prediction? How do I use the equation we got from the calculator and the year 2004 to make a prediction? First of all, I wouldn't use the number 2004. What number would I use? Did we change our measurement in the years? Ooh. What the heck number do I use for 2004? What did I use for 2000? No. The year. I didn't type in the number 2000. I put 100. So what do I put for 2004? 104. And where do I put that 104? So what do I put for 2004? 104. And where do I put that 104? Well, I mean, for the equation right here, where do I put it? Say again? Well, I'm trying to make a prediction. I'm saying, where do I plug in that 2004? Represented my year.
A.
There's no A in there.
Well, the A column.
Why? It's X. It's X. I know. Going back to here again, I erased it on the board before. This is going to be something of a measurement of time for the most part. Sometimes it won't be, but if you ever have time is typically in that timeline on the x-axis. And you can see stat edit. I entered in the number of years, as you said, into L1, but keep in mind that that was my X list. So what I'm going to do that's what I'm going to calculate. Instead of X, and I'm making a prediction, 6.312. We're making a prediction. And you can see that. We're making a prediction. And you can see that right there. 2004 Olympics. By the way, fun fact, anybody know where the 2004 Olympics were held? Come on, know your history.
Oh, no. I don't know. I was a year-old, so I don't watch it.
Whatever. I didn't either. It was in Athens. Athens, Greece.
I was watching the gymnastics part.
Okay, of course you do.
Yeah, that's my favorite.
So let's see. 2000 winning height, 5.95. Now perhaps we'll add that number in to our scatter plot in a little bit. Maybe, maybe not. We'll see what happens. But that's 5.95. Timothy Mack, USA. I don't know. I don't know who is actually who have been champions for the pole vault. Pole vault at the Olympics. Here we go. Gold medals. Sweet. Oh, wow. Yeah. Recently. Oh, cool. Okay. Sorry. I'm just looking at the countries that have won it. It's all over the board. France, Germany, United States, Russia. That's crazy. Anyway. Here. Whoa. Yo, read that. What was the winning height in 2008? That doesn't really seem like too much of an improvement. That doesn't seem like too much of an improvement. 5.96. Here's what I'm going to write on my paper. Look at this for part D. It says use the model to predict the pole vaulting height at the 2008 Olympics. What was the actual gold medal height and by whom? I don't care by whom. The guy had hair. Is this a good prediction? Well, I don't know what my prediction would have been. Let me use the equation. If I'm going to use the equation, 0.028 times 108 plus 3.4. Let's see what that would have gotten me. See, now we're getting a bit farther away. Now we're getting a... We'll see what happens. We will see what happens in a little bit. We are gonna add in the actual data points into the L1 and L2, and we'll see how it compares to the other equation. You'll see. You're getting a tiny bit ahead of me, but you are absolutely on the right track. Yeah. I remember because during the opening ceremonies, a lady pretending to be the Queen of England parachuted out of a helicopter with James Bond. I don't know. Am I the only one? All right. Whatever. You guys were old enough. You were like 8, right? Whatever. Anyway, let's figure out what the prediction would be first. 8 times 112 plus 3.4. There's the prediction. 6.536. Holy crap. What is it? 5.97. Oh my gosh. It seems to me, going back to here, it seems to me that our predictions keep going up by a larger number than the actual pole vaulting results. Predictions keep going up by a larger number than the actual pole vaulting results in those years. Heights keep incrementally going up by like 100th But then our prediction keeps going up by a tenth. They keep getting farther and farther apart. Let's rerun that analysis. Here's what we're going to do. Yes. Oh, 2004, 2008, 2012, it went from 5.95, 5.96, 5.97. Now, that's just a coincidence, but it doesn't seem like it's improving all too much. I don't know. Let's go back to our graphing calculators. And let's go back to stat, edit. And in these years, I want to add in 2004, 2008, and 2012. And as you said, let's see how they affect the prediction line. I'm going to have to rerun an analysis, but I'm going to type in these times here. 6, 5.97. I'm going to hit stat. I'm going to go to calc. I'm going to go to linreg. Well, calculate. And it's going to rerun the analysis. Now, I'm not going to change anything on my paper. But here was our original equation, which was y equals 0.028x plus 3.4. And here is our new equation, y equals 0.026x plus 3.5. You know, I'm going to round to more decimals. Different. Oh, the slope was pulled down a little bit. Let me change my equation here. 0.0256x. Yeah, wow. Look at that plateauing. Just added in those 3 extra points. You used a phrase before. I think you said something like it would kind of like pull it down or some junk like that. That's exactly what it did. These 3 extra points kind of pulled the line yet. I don't know. Perhaps these 3 years were anomaly years. Maybe it was supposed to go like that. I don't know. It's insane. Do you know how much an Olympic, like let's say like swimming or sprinting world record, do you know how much like a record is broken nowadays? Right, like the world records, they keep going up, but they're like, as you know, I said and as Sky said, they're plateauing. Linear regression may not be the best for defining it, but it's the best that we have at the moment. Yeah, unless, you know, steroids. That remains to be seen. I don't know. So, here's what I want to do. For the sake of argument, I kind of just want to see what the 2016 Olympics was. There's a larger leap. I mean, it wasn't too much of a larger leap, but it was better. Say again? Yeah, we were supposed to, but now they're not. Or, I'm sorry, in 2020. So now they'll be held in 2021. Olympics were held in the same year. Did you know that? 1992 was the last time they held them in the same year. And then in order to fix the Winter Olympic schedule, they had a 1992 Winter Olympics and then a 1994 Winter Olympics. And then they need you to have those notebooks out and open. The what? Yeah, if you want to, that's up to you. Yeah. I need you to have those notebooks out and open. Let's see. Let's call this linear. Today is the 8th. Now this is going to be brief, simply because I kind of anticipated we would be talking about linear regression. So to enter your data, we're going to hit stat in L1 and L2. So for just briefly going over the procedures for what you need to do in order to run a proper linear regression. Put your information in L1 and L2. From there, in order to get your scatter plot, y equals enter to turn plot on. So again, in order to view the scatter plot, we're going to hit second y equals enter, turn that plot on. Everything else, so it's just a matter of, it's already set to scatter plot. It's already set to L1, L2. Don't change it. Don't change anything else. Then, in order to change the window, you're going to want to hit zoom. Now with this, there are going to be various things that we can do. The direction and form of the scatter plot to be a linear form. We're hoping it to be a straight line, but there are certain instances in which you may not get a straight line. But we can still describe the direction. If it's a line, we can describe it as being a positive line or a negative line. If it's not a line, we can still potentially describe the direction if it's, let's say, exponential, quadratic, or what have you. Along those lines, you can describe the pattern that is in front of you with that scatter plot. If we choose to run a linear regression, here are the steps that you would have to follow. You would tab over to Calc. And you would hit the fourth option, linreg. Of course, you want to calculate that. Running that regression, this equation. Now, obviously, it is just a prediction equation. Not all predictions are accurate. Some predictions are far off. Some data points will vary. They will vary greatly. Now, I'm going to do something on my calculator right now. But I'm not going to tell you exactly what it is that I'm doing. I'm done writing stuff, but I want to show you something. Okay, watch what happens. I'm about to run this linreg, but I changed one setting in my calculator. I'm not going to explain exactly why or how or what. We'll do that next time. But I wanted to show. Look at this. These two numbers are incredibly important. Now, next time I'll show you how to get these two numbers. But these two numbers do some very important things in regards to the linear regression. The letter R actually describes the strength. R squared, which if you can't figure it out, you just square the R, you get R squared. But R squared tells you the percent of the variation in kind of how good of a prediction model that you have. There is still one more thing that determines whether or not our model is basically going to be acceptable or not, but that is for next time. So, next time we come in, I'm going to go over this pole vault data one more time with you. I won't have you re-enter the data. I'll just enter it in myself because whenever you close out the calculator, it just automatically resets. So I'm not going to have you re-enter. This key to determining whether or not our linear model is appropriate, or if we're going to have to do something else. Anyway, I know, cliffhanger ending. That's what she called it. You know, cool. So as a reminder, you have that assignment. Yes, it's the same PDF for binomial geometric. If you have any questions, email me, and we'll get that thing done. Anyway. Oh my goodness, it's Friday. Can I tell you that this has felt like the longest week in the world?
You know, this thing was like actually.
It's super.
Here, like, everyone feels like the week was long, you know?
Yeah.
No one's like, oh, this is good.
No. I think it felt long because there was an attempted coup in the Capitol. But that's another story for another day. Anyway, I'm going to sign off.